Alibaba Cloud Native team. Today, I will introduce how to manage your Kubernetes clusters on multiple cloud or hybrid cloud. In recent years, there's been much talk about multi-cloud and hybrid cloud. Multi-cloud and multi-cluster architectures can provide benefits such as high availability and multi-region zones. At the same time, both types of architectures can also reduce vendor dependency, which in turn offers a host of advantages, such as reduced cost, reduction in the need to store data with a single vendor, and the ability to take advantage of the best features each vendor has to offer without being locked into one particular cloud vendor. Multi-cloud, hybrid cloud strategy has been talked about for a long time and been considered to be the next big thing. However, the sad reality is that each cloud platform and each data center has its own set of APIs, which makes multi-cloud strategy a pretty complex combination. Things changed for the better with the rapid popularization of the concept of cloud native. Kubernetes has made application delivery increasingly standardized and completely decoupled from underlying infrastructure. The popularization of Kubernetes APIs has built a solid foundation for multi-cloud and hybrid cloud architectures. Managing Kubernetes clusters on multi-cloud or hybrid cloud is the last mile of multi-cloud and hybrid cloud strategy. There are a couple of ways to manage multi-Kubernetes clusters. The first finger is designed for the multi-site active-active scenario. The typical character of this scenario is that all clusters are read, write, and the data is synchronized in real time. Using Global Traffic Manager to assign different weights to different clusters based on resource allocation. The second finger shows how to use microservice registration and the discovery mechanism to manage applications on multiple clusters rather than manage clusters themselves. It deals with sudden burst of resource demands and use multi-cloud setups as backup resource pools. The third finger shows how to use Alibaba Cloud Container Service to manage Kubernetes clusters anywhere centralized. It also provides consistent management experience and easy integration with Alibaba Cloud middleware for all Kubernetes clusters. The benefit of using Alibaba Cloud Container Service to manage multiple hybrid cloud Kubernetes clusters are as follows. First, it provides unified management to all Kubernetes clusters using Kubernetes native operation method. Managing all your Kubernetes resources from the same portal provides consistent experience, such as security compliance, application management, observable scaling, and cluster audit policy. Second, all managed Kubernetes clusters can apply the same logging, monitoring capability by integrated with Alibaba Cloud middleware. Integrated with Alibaba Cloud SLS for logging management, integrated with ARMS to gain application performance observability. Third, you can take advantage of the scalability of public cloud by integrating with serverless resources. You can have an infinite resource pool which can respond to traffic spike without service interruption. The typical scenario of multi-cloud deployment is active-active mode. The first reason why you use this deployment is disaster recovery. This topology achieves cloud vendors' resilience and regional resilience. If one of your critical service experience issues, you might want to shift the traffic to a healthy vendor. It is not possible to prevent threats to availability, but it is possible to mitigate them. The second reason is improving latency for end user. The closer your backend origin is to end user, the better the experience. To achieve these goals, you can use Global Traffic Manager to route the user access traffic of an application service to different clusters. GTM uses the DNS Smart Resolution and the application service's running status health check to direct the user access request to the most appropriate IP address. GTM provides smart resolution based on network area and health check based on PIN, TCP, or HTTP/HTTPS. It can be used to build SimCity multi-active and remote disaster recovery services flexibly and quickly. With regard to cluster management, federation can be used to push cluster configurations such as role-based access control policies and other policies to multiple clusters. CI/CD is usually used for application release management. GitOps is a good choice for continuous delivery because application definition, configurations, and environments should be declarative and version controlled. Application deployment and lifecycle management should be automated, auditable, and easy to understand. With regard to microservices management, Istio provides traffic management, security, and observability. Services running on multi-Kubernetes clusters can securely communicate with each other transparently. Kubernetes clusters could be running anywhere, even in different cloud platforms with Istio multi-cluster services mesh mechanism. Another typical scenario is dealing with sudden burst of resources demands, which is so-called cloud bursting. If an organization using a private cloud reaches 100% of its resource capacity, the overflow traffic is directed to a public cloud, so there's no interruption of services. In addition to flexibility and self-service functionality, the key advantage to cloud bursting is economic savings. You only pay for the additional resources when there's a demand for these resources. An application can be applied to the private cloud, then burst to the public cloud only when necessary to meet peak demands. Your workloads running on both public cloud and private cloud can register to the centralized registration for service discovery. Clients of a service use either client-side discovery or server-side discovery to determine the location of a service instance to which to send requests. So the microservices can communicate to each other no matter where it is running, on the same cluster, on multiple clusters, or on a hybrid cluster. The object of the multiple cloud hybrid cloud management is application rather than cluster. This slide shows how to register external Kubernetes clusters to Alibaba Cloud Container Services for centralized management. To connect Kubernetes clusters to multi-cloud management system through Kubernetes API hosting, the main technical challenge lies in establish cluster tunnels. The cluster tunnel installs an agent in your Kubernetes cluster on a private network, which enables access from the public cloud. With this tunnel, users can access your Kubernetes clusters as if it were running on a public cloud without the need for public IP addresses, and use, manage, and monitor your clusters anytime, anywhere. Features such as authentication, authorization, logging, audit, and console are controlled from a single point, no matter how many clusters and where the clusters is. There are two layers of this architecture of Cloud Tunnel. The lower layer is a hosted cluster with an agent for each. The agent runs in the hosted cluster and are able to access resources on the private cloud. The agent runs in the hosted clusters and are able to access resources on the private network which the cluster resides. They are also responsible for establishing tunnels that connect the private cloud. They are also responsible for establishing tunnels that connect the private network to the public cloud by using stubs. The upper layer is composed of cloud on the public network and is responsible for centralized authorization, authentication, and audit. Commands for the private Kubernetes cluster are passed to the agent through the tunnel. Registered Kubernetes clusters are taking advantage of the features provided by Alibaba Cloud, such as cluster audit, logging management, application performance management, and application high availability service. Another advantage of register your Kubernetes clusters to Alibaba Cloud Container Service is utilizing serverless resources. Adding a virtual node to your cluster equals to adding an infinite resource pool to your cluster. The scalable unit is pools rather than node. which means results can be ready much faster to respond to traffic spike. The technology behind the virtual nodes is Elastic Container Instance, which is an agile and secure serverless container management service. ECI provides you with the capability to run containers without having to dedicate resources to manage servers or the underlying infrastructure. Containers can be easily set up from just a container image, and you are charged only for the results consumed by your container. With multi-cloud hybrid cloud 1.0 architecture, Alibaba Cloud's container service provides unified cluster management by registering external clusters to Alibaba Cloud Console, which provides cluster federation, governance, monitoring, and backup to centralize manage multi-clusters with a consistent experience. In 1.0 architecture, all managed clusters are integrated with Alibaba Cloud middleware easily with zero intrusion and low cost to take advantage of the capability for logging, monitoring, security, and high availability. With 2.0 architecture, Alibaba Cloud Container Service extends the unified management to application level. Alibaba Cloud Service Mesh is a managed service mesh solution to provide traffic management, security, observability for services running on multiple clusters. This slide shows how to manage multiple clusters with a single mesh to achieve multi-region active-active architecture. Multi-cluster deployment gives you a great degree of isolation and availability, but increased complexity. If your system have high availability requirements, you likely need cluster across multiple zones and regions. You can carry configuration changes or new binary releases in a single cluster, where the configuration changes only affect a small amount of user traffic. Additionally, if a cluster has a problem, you can temporarily route traffic to nearby clusters until you address the issue. Inter-cluster communication are based on Cloud Enterprise Network, which is a high availability network built on the high performance and low latency global private network provided by Alibaba Cloud. By introducing Service Mesh, you can extend multi-cloud hybrid cloud management to application level for unified traffic management. Okay, let's see the demo. In this demo, I have a Kubernetes cluster set up on another cloud vendor. I'm gonna register it to Alibaba Cloud Container Service. First, let's create a register Kubernetes cluster. It sets up the stub on Alibaba Cloud, which is used to communicate with the agent installed on the external clusters. I'll choose the region and accept the terms. It will take a couple of seconds to complete. Okay, after completion, you can see the placeholder cluster listed. The status is to be connected. Click Manage to get the agent YAML file. Copy the YAML file, which will be created on your external Kubernetes cluster. Okay, let's go back to your external Kubernetes cluster. You can see there are 3 nodes for this cluster. Let's create the agent. Wait for the agent to be running. Now go back to ACK console. you can see that the cluster status has been changed to running. And there are 3 nodes for your external cluster. Next, I'm going to deploy an application Helm chart into your external cluster from ACK console. Let's go to your third-party cloud platform and check there's no service. Okay, I'll create an Nginx application using Helm chart from ACK console. Make sure that you choose the correct cluster. Okay, let's go back to your third-party cloud platform. You can see there's a service created, and you can access the service from the load balancer IP address. Okay, let's go back to ACK and delete it. Let's check again. You can see that the service has been deleted from your external cluster. Next, I will demo how to integrate Alibaba Cloud Service into your external cluster. For the registered Kubernetes cluster, you can enable audit logging capability. Once enabled, the audit logs will be recorded to track the operation that modifies configuration or metadata of a resource. From the cluster auditoring page, you can see the predefined dashboard for Kubernetes Audit Center. You can see the public visit and unauthorized visit to API server. You can see the location of the client to visit the API server, and you can also see some sensitive actions. And you can also see some operation overviews. It has actually every actions to your app objects in Kubernetes cluster. Next, I will demo how to integrate your registered Kubernetes cluster with Alibaba Cloud Middleware. The first middleware to integrate with is Application High Availability Service. AHAS is a product that focuses on improving the high availability capability of applications. By integrating AHAS within the registered Kubernetes cluster, you can build the functions such as automatic detection of application architecture, high availability evaluation of fault injection, and one-click flow control degradation, which can quickly and cost-effectively improve application availability. Go to the AHAS console. You can see the architecture map for your external registered Kubernetes cluster. From container level, you can see the status of your container installed on your registered Kubernetes cluster. You can, from a Kubernetes perspective, you can see the deployment. From host perspective, you can see the node status. Okay, the next Alibaba Cloud middleware I'm going to demo to integrate with is ARMS. Application Real-Time Monitoring Service is an application performance management product of Alibaba Cloud. By integrating ARMS within the registered Kubernetes cluster, you can quickly and conveniently build business monitoring capability within few seconds response time for business and enterprises based on customer dimensions such as the browser, application, and business. To enable ARMS integration, you just need to add annotations to your pods YAML file. Let's go to the ARMS console. From the console, you can see the status of your application for each request. And from application details page, you can see the request flow and the time consumed for each request. In this demo, you can see the advantage of register your external Kubernetes cluster to ACK console. First, you can have unified management console. And second, you can easily integrate your external Kubernetes cluster with Alibaba Cloud middleware.
Hi everyone, my name is Jager. I'm solution architect from Alibaba Cloud Germany team. I'm working with customers on cloud migration, data analytics, machine learning, and many different other topics. The most fundamental and critical task for the customer is to automate the CI/CD process for onboarding to the cloud, which is continuous integration and a continuous delivery. Today, I would like to give you a short introduction about two very famous CI/CD components, which are Terraform and Helm. Let's first take a look at the agenda. So I will brief you the Terraform and Helm, and afterwards, I will give you some insight about how the typical cloud architecture look like with the customers. Then we will have a closer look on the challenges and potential solutions. Finally, I will present you a demo to demonstrate how the tools can work together. I bet most of you have already heard of Terraform and Helm, and some of you may already use them in your daily life. Terraform is a tool to support you with infrastructure as a code technology. You can write declarative configuration files for your cloud resources, and you are able to plan and predict the changes before you apply to the cloud. And after all, when you have ready with one environment, you can easily reproduce them in the other environment. And Helm, on the other hand, is a product lifecycle management tool which helps you to manage the complexities in your development environment, especially when you have a microservice concept, you have multiple services and components that you would like to combine them together as a product. So with Helm, you can easily update your complete solution, and you can share this easily between different environments. Finally, Helm enables you to roll back the solution when it doesn't work as you are expected. So let's take a look. What happens when you use a tool working with the cloud? So when you run the Terraform, you first need to select a provider. So in our case, we take Ali Cloud as one provider, and we take Kubernetes and Helm as the other provider, running against our Alibaba Cloud container for Kubernetes. So you need to have a target region, which we will use Europe Central 1, and you need to declare your resources. Let's say you have A, B, and C. Finally, you want to have additionally with a Kubernetes cluster. And afterwards, you need initialize your environment with your state synchronization with the cloud. And then you will have your plan to print out what exactly will happen. Finally, after the review of your plan, you will apply your resource to the cloud. After you finish the apply command, you will see the resource A, B, and C will be deployed together with Alibaba Cloud Kubernetes cluster. And when you run the provider Kubernetes and Helm, you will deploy directly to the targeting cluster. In our case, it's Alibaba Cloud Container Service for Kubernetes. So all your dependencies as a Kubernetes resources will be deployed to the targeting ACK. On the other hand, afterwards, you will hand over the ready environment to your development team. So they will package their solutions, including ingress, services, deployment, and cron jobs in the Helm package and deployed also targeting to the ACK cluster. So afterwards, your solution is good to run. Let's take a look at the typical cloud architecture design on the most customer side. This is a typical development landscape. This demonstrates most of the customer's daily work. So they first have a development environment. After some basic tests, they will deploy to the staging. And when they're satisfied, they will move to the production. At the same time, For the development and staging, they usually try to make it internal access possible and verify with the internal users. And for the production, they usually have external entry point and will be used by the end users from external. If we have a closer look to the development environment, we will see that most of the case, they have a running platform like Alibaba Cloud Container Service for Kubernetes, which is running their applications, their services, and the dependencies. They need a database. Most likely, they will use RDS MySQL in Alibaba Cloud as a managed service for database to store their data. And additionally, they need to manage the domain service, the certificate management, the key management service, how to monitoring, and how to log all the required resources. This doesn't sound very complicated, but let's take a closer look on the challenges, what they usually see, and what could be the solution proposed to them with the DevOps. So the most commonly asked questions are the following: how to make sure the development, staging, and production environment are exactly the same. This is a challenge to all the development team. So after all, they need to make sure what they have tested and working should be the exact one that they release for their customers. Also, they want to know how to review the changes before applying to the cloud. So most of the customer want to know the consequence when they create the resources or when they modifying the resources. They want to know what will be the impact. They would like to see what other resources will be also involved for this change. And not only in the resource change, customer also want to know how they can successfully upgrade the environment, how they're able to upgrade the solutions from the development environment to the staging environment, finally launched to the production. And sometimes the customer will also ask a question on the solution lifecycle management, how they're able to ensure the solution delivery completeness. Finally, the most critical part, how to automate the DevOps process for the above mentioned points. Our answer is infrastructure as code and product lifecycle management, which refers to today's topics, Terraform and Helm. How the solution look like? Let's first take a look at the environment. Let's assume you have a dev environment, which is Alibaba Cloud account. And the first thing you need to do is to make sure your account is valid for the enterprise. Additionally, you need to make sure that all the services you need are already activated manually. After that, we can start our automation journey. So the most important part at the very beginning is to set up your resource access management. This includes the user setup, the role setup, and the policy setup. Afterwards, you can use the user or the role you have created in the first step to set up your cloud managed service. In our example, you will see the managed Kubernetes, KMS, RDS MySQL, and log service will be deployed using Terraform. After the managed services are deployed, you can configure the dependencies in the Kubernetes environment. So with that, you want to have dependencies which is able to handle the domain service, the certificate, and the monitoring. For the monitoring service, we'll mainly talk about Prometheus and Grafana. And last, you can hand over the infrastructure and ready-to-use environment to your development team. They will deploy their applications using Helm. And the solution is ready to use. How we're able to verify it? First, we will check the domain name will be automatically generated and enabled. We will see the certificate is automatically managed. We will see that key management service is able to synchronize with your Kubernetes secrets to be able to access the database. We will see the logging is already visible and the monitoring is already configured. With that, we will see a happy user face. Let's revisit the DevOps steps. So the step 1 is a manual preparation. You need to make sure you have account ready to be used. And then you need to make sure all the services you plan to use are activated. Optionally, if you plan to integrate with Active Directory or Azure AD, you need to make sure you have finished the integration. And from step 2, we will use Terraform to automate the RAM user, the RAM roles, and RAM policies. At step 3, we'll make sure your managed service will be deployed using the RAM users or the RAM roles. This includes the Kubernetes cluster, RDS database MySQL, the log service, and the KMS. In the step 4, we will make sure that your dependencies in the Kubernetes cluster will be deployed properly using Terraform with provider Helm or Kubernetes. The dependence includes the third manager, external DNS, external secrets, Prometheus operator, and log exporter. So finally, in the step 5, you're ready to go with your application deployment. So in this step, we'll use Helm to package the solution, including deployment, secrets, service, ingress, and deploy it to your Kubernetes cluster and make sure they're working. Before we start the demo, I would like you to know that my demo is already accessible from public internet in GitHub. And I'm using Traverse CI as a CI/CD pipeline to deploy to the Alibaba Cloud for testing purpose. If you want to find more detail, just visit my GitHub. Okay, let's start the demo. So this folder is which I have already shared in the GitHub. Let's take a look what is inside. So there are 3 folders. In the demo, I will demonstrate how you deploy your applications using Helm. And there's a script I wrote for automating the pipelines for Traverse CI. And in the Terraform folder, where are the resources we'll deploy via Terraform. I have also a local bash prepared for my environment values. I have already exported all the environment values. Okay, let's take a look. So within the Terraform folder, there are 3 folders we will run the Terraform, and there's also a shared folder called modules, which provide the resources that can be shared across different folders. So in the account setup, we will deploy roles, users, and policies. In the cloud services, we will deploy the managed service in the cloud, including Kubernetes, KMS, log services, and RDS MySQL. And for the setup, the last step will be installing the dependencies in the Kubernetes. And this will be done in the Kubernetes service folder. Okay, let's start from the account setup. So if I run Terraform init, I will initialize the modules, backend, and providers. In my case, I have already done it several times, so it's already in it. So we can run the Terraform plan to see what will be deployed. Okay, so let's take a look from the beginning. There will be DNS policies that will be used for the DNS automation. And then there will be the policy for the external secrets to synchronize the KMS with Kubernetes secrets. And there will be the STS policy for kube2ram, assuming roles. So they're all different policies, and afterwards will be attached to user or role. Okay, let's run it. So I will run Terraform apply with auto approve to avoid interactive approval. So you can see all the resources are generated already. With the result in green, apply complete, resource 9 added. Now we can move to the next folder, which is the cloud services. And the same, we will run the Terraform init first to make sure all the modules are loaded, the backend status are synchronized with cloud, and all the plugins are already initialized. The same afterwards, we will run Terraform plan to see what will happen. If you have already the resources deployed, this one will refresh the status and tell you which will be added and which will be deleted. So this will give you an overview on what you will trigger in the action. So let's take a look. So in this case, we will create database account, which of course will after the database instance, and privileges for the database schema, database instance will be triggered first. And of course, we will store the secrets in the KMS for the database secrets. And overall, there will be the VPC created on top and a vSwitch for the cloud resources where our managed Kubernetes will be sitting in. And we will also try to load the role that can be assumed from the management Kubernetes cluster. We will create log service for the Kubernetes, including log store and index. We will also attach the policies to the managed Kubernetes default assume role. And we will give the SSH and RDS access possibility from the security group. I will also run the Terraform apply with auto approve. And you will see they will first calculate the dependencies and the sequence and then run the code. So for those who can run together, they will run together. And for the dependency relationship resources, they will run sequential. So the automation will take around 10 minutes. During this time, let's take a look what will happen. This is a script for running the complete installation. So you see there will be account setup, which we have done. And what we're going right now is to deploy the services within the cloud service folder. Afterwards, we will use the Terraform output functionality to export 2 values into our terminal. And we will update the kubeconfig to feed into the kube context. We create the secrets for using the Alibaba Cloud container registry afterwards. We cannot automate this part in the pipeline because we also need 2 environment value to be injected here. And Terraform provider right now does not support the customer resource definition. So we will deploy the log CRD via kubectl apply, which will help us to link the log service and Kubernetes cluster. So afterwards, we will make a small tweak in the ingress. And after those glue code, we will be able to run through the Kubernetes service. And also on the left side, let's take a look at the modules. So there are modules for RAM, VPC, secrets, which stands for the external secrets, synchronizing between KMS and Kubernetes secrets. the RAM role, KMS certificate, which is the cert manager deployment, application real-time monitoring service, and Alibaba Cloud Container Service for Kubernetes. So within the code, if you want to refer to the modules, you can simply say module, and then the module will be deployed with the values that you provided here. Okay, let's look back again, see the status. Now you can see the database instance and Kubernetes are running parallel, so they do not have dependency relationship. So they will be created at the same time. So one is completely finished. You can see we have the outputs, the cluster ID, and the database connection string. So remember, we will run the glue code in between. We'll copy the code here, and we will paste it here. So you can see the secret is created, the log CRD is deployed, and the Nginx ingress is updated. So now we can continue with the Kubernetes dependency services. We need to move back to the Terraform folder again, and then to the Kubernetes services. The same, we will run Terraform init and Terraform plan. Let's also take a look. So the application real-time monitoring service, which is a managed Prometheus, will be deployed. We provide the cluster ID, the region ID, and also the account ID. There will be also namespace created for that. And we will deploy cert manager using the Helm provider. We also generate the namespace for it. We will create the cluster role for external DNS, also for kube2ram. And here we deploy the kube2ram. External DNS, and some necessary privileged service account for it. And here we deploy the service manager, which is Alibaba version of external secrets. Now let's run it. So in this case, Terraform provider Kubernetes will try to collect the information in the cluster, and afterwards upgrading or deploying directly the Helm chart, the deployment, the privilege related service account role and role bindings directly to the cluster. This will also take around 1 minute. Okay, finally, after 2 to 3 minutes, all the dependencies have been deployed. Now we can continue with the demo. So we have prepared 2 demos. One is using the Helm chart to deploy the applications. The other one is to verify the basic functionality of the cluster. Let's first go to the demo 1. There is a very simple YAML file. We can see in the YAML file, there will be ingress, service, and deployment. And the deployment is very basic Nginx image. So how we evaluate? First of all, we need to make sure all 3 can work together. There will be load balancer created in the service, and will expose the application in the port 80. Additionally, I have also said in the file that external DNS shall generate a new record. The same in the ingress. So in case the customer want to go through the ingress, there will be another record generated for it, and which will be routed to the service name demo01 from 80 port. Okay, let's deploy it. All of them are generated. So we can take a look. What is now you can see there's a demo1 service record generated here, and there's a demo1 ingress record generated here. So with that, I will simply test if this one works. Okay, this already gave me the welcome to Nginx, which means it's already working. And I will also test the URL using the ingress. It also works. So I think the basic functionality is already there in this cluster. I will start my demo with demo 2. So in the demo 2, I've prepared a folder which called Hello Helm, which is a Helm chart I've generated in this folder. So this is my IDE again. I opened the Hello Helm folder in my IDE. You can see in the template, there will be a deployment, an ingress, an issuer, which support me with issuing the certificate. And then there will be the secret. The secret will help me to synchronize the value from KMS and secret in Kubernetes. And on top, I have a service for my deployment. So you define variables in your values.yaml. So you can see that I have a service with type load balancer from port 80 pointing to my deployment on 8080. I have enabled the ingress with cert manager, and I will use external DNS to generate the record for the demo 2. And then the cert manager will issue the certificate for the SSL. I define the TLS secret name and for which host. Okay, now we can run it. So we will run the helm install command. Give a name test, pointing to the current folder. We'll use debug mode to see what will be generated. And we will provide also the connection string for RDS MySQL, which we generated from the Terraform outputs. Okay, look like it's already deployed. You see, when we're deploying, all the values will be automatically inserted and adapted from values to the YAML file. Okay, let's take a look what is currently already deployed. So you can see I have demo 1 from the last demo is in the running state. I have a demo 02, which is for this one that we're connecting to the database. And I have also generated the certificate management issuer, which is for the ACME type. Let's first take a look what is happening in my demo 2 deployment. Okay, you see, this is a Java application. It's already booted. So I use a Liquibase to generate the table directly. So you can see the table is already generated, which is using the secret that I synchronized directly from KMS. And when it's finished, the table generated and the server is ready to go. And we can already run it to verify if everything works. So let's say I will go to the API call. You see there's no person there. And I can also add another value here. So in my case, the application takes the body with name and address. I will give my name, Jager, and Frankfurt am Main to the endpoint add. So it looks like it's working. If I curl the API again, you should see it's already persisted in the database. So the functionality basically works. Now we can use a browser to validate the HTTPS certificate. It works. You see, the icon is showing that the certificate is valid. And if we take a look, it will also tell us this one is for the URL demo2 ingress and is issued by the Let's Encrypt. Okay, so everything works the website. Now we can take a look at the additional functions. Log into my web console, go to the log service, and you can see the project is already created. When I click on the project, all the log store will show up here. So when you open the log, you can see all the pod log is already injected into the log service. And in the detail, you can see this is from the namespace kube system. This is for the container metric server. You can also click on the namespace to filter it out. And then you can see all the logs will come from the kube system. There are more functionalities in the log service for searching, for visualization. You can also check the automatically generated ingress. So there is a search functionality already provided by default. And additionally, there are also the visualization dashboard. You can see there are already listed dashboard generated for the ingress. You can always create your own dashboard here. So this is a log, and let's take a look at the monitoring service. Now I log into the monitoring service, and you can see this is already linked to my Kubernetes cluster with the type managed Kubernetes. And it already generated several dashboards for it using Grafana. So we can take a look also for the ingress. Okay, now you can see the ingress dashboard is already loaded. This is standard Grafana, so you can create your own dashboard. You can also configure the components here. So everything is the same as the community version. Okay, that's my demo today. I hope you enjoy it. And this is the GitHub. I shared all my code. You can find helpful information there. If you have any requests, please contact me via email or GitHub. Thank you very much for watching the demo.
Okay, that's the end of the training. So I hope you all enjoy the training today. And we will have a 1 hour break before the exam. Just a quick reminder for the Global Summit event. You can sign up here. Let me send it to you again. Okay, give me a second. I'll send it to you after I finish the live stream. So please be back at 1 p.m. and follow the instruction from the email exam that we send it to you. So okay, good luck for today's exam, and yeah, I'll see you at 1 p.m. Bye.